Alright, so this is the fourth and final video for the Year 12 mock exam. So this is a more theoretical look at some circuitry. So we've got three resistors, 3, 4 and 6 ohms, and the first question asks you to draw the arrangement that gives the largest resistance. So the largest resistance is going to be the three of them in series, so hopefully nice and easy. Three resistors in series, you've got your 3, 4 and 6 looking like that, and the resistance of this would be 3 plus 4 plus 6, giving you 13.0 ohms. I was a bit sloppy there. They're all given to a precision of 0.1 ohms, so your final answer should also be given to a precision of 0.1 ohms because we're adding the numbers together. So then it wants the arrangement which has the smallest. So the smallest would be where the most pathways essentially between them. So that means them in parallel like this. Very rough diagram. Something like that. And then we'll label the resistors in there like this. So then it wants us to calculate the resistance of that. So 1 over the total resistance would be 1 over 3 plus 1 over 4 plus 1 over 6. So if we put those all over a common denominator of 12, it would be 4 plus 3 plus 2, which is 9 over 12, which means that the total resistance would be 12 over 9, but we don't give answers as fractions, this is physics, and two significant figures would be appropriate because all of these numbers up here are two significant figures. So calculate it, round it to two significant figures, you get turn out as 1.3 ohms, remembering not to write 1.3 recurring as that would be infinite significant figures. So 1.3 ohms is the correct answer. We've got them now connected in this configuration with 0 internal resistance, and it wants the total resistance of the circuit. So let's first of all calculate the resistance of the parallel section, like this. Let's put them over a common denominator of 6, so it would be 2 plus 1, so 3 over 6, which implies the resistance of the parallel section is 2.0 ohms. So then to get the total resistance be 2.0 plus 4.0 gives you 6.0 ohms. Like this, that gives you the total resistance. And it wants the potential difference across the 6 ohm. So I'm going to do this with potential divider equations. So I want to know what the potential difference across this one is. So it's going to be the EMF times by the resistance of the parallel section over the total resistance. So the EMF is 12. The resistance of the parallel section is 2. The total resistance is 6. So when you calculate that, that will be 4.0 volts. There are several other ways of doing this. You can calculate what the current is, work out what the potential difference across this one is, and subtract it from 12. That would work also, but this one's a nice and simple way to do it, especially given that you've already calculated what the resistance of the parallel section is as part of your working here. Okay, so this is the end of the mock exam, and those are all the solutions.